Man-made radiation is very different than natural radiation.
The problem is that people are so addicted and reliant on these things that they're really exposed to it at the maximum level, and it doesn't leave you ever.
What we focus about on that radiation is how those photons really interact with the body and what they can cause.
All right, guys, welcome to another episode of the Bodywell Podcast. My name is Liel. Today with me we have Jor Levy, the CEO and head of research at Bodywell. Today we're going to talk about an interesting subject. A lot of people will talk about ionizing versus non-ionizing radiation, and cell phones specifically fall within its own category that we'd like to discuss. So please tune into the video, and let's get right into it. Now I really want to get into just a brief explanation to the general public about radiation, like what is it, why do our devices need radiation in the first place, and then I want to dive deep into man-made versus natural radiation and really what's the difference.
Radiation is actually a form of energy that that it's emitted, and then we're actually using it to transmit the information via the wave, right? Yeah. But almost it's in, when we say just radiation in general, it's everywhere, right? Yeah. It's the sun, is the heat, is the earth. Almost we actually
our bodies.
Yeah, our bodies. Everything has in a way radiation, right? So that's why it's important to understand that radiation cannot be the problem. Mm-hmm. Since we're actually using it, our body produce vitamin D, with radiations. So it's not necessarily not bad. We're going to try to concentrate and also debunk the position that usually says, well, the sun or the visible light are much stronger. So if they're much stronger,
then cell phone radiation
cannot do anything, right? So we're going to go a little bit to that technical part. I'm trying not to go too deep, just so we're going to have a kind of understanding how it's works. So we want to start with what we call man-made radiation. Man-made radiation is very different than natural radiation, where biologically, a body adapts for millions of years to take radiations from nature in a different form and use it for their own benefits. Man-made radiation, on the other hand, are something we call coherent and polarized. What it's actually, if we want to try to understand what it's mean usually that it's much more concentrated. I mean, we can see it, for example, laser light can be only 4 watt and can blind you, compared to thousands of watts of lights, natural lights.
From the sun.
Yes, that's not going to do anything. So the first thing is that that is very concentrated, right? And this is really the same thing that we use microwave oven, stuff like, and other forms of that. But then we have something called, we're doing something called modulations on that, right? So when we do the modulations on that radiations, on that wave, really, we do modulation. It's like what used to be in the past, we know AM and FM radio, for example. So, AM, it's amplified
amplitude
modulation, and then frequency modulation, right? So it's like the height and the width. And then on those actually radio waves, we actually use something called analog generators,
signals.
Right? Yeah, so analog, it's very similar to how natural work, where you have that wave, the sine wave, that is like the S wave,
yeah,
right?
The sine wave is just smooth.
Exactly, and this is actually still biologically can be accepted, but today we actually use digital wave. Digital wave, it's just 0 and 1. It's just
binary,
right? So it's actually square wave. So if you want to see it, and this is where the confusion starts, because the wave from the description of their length or the frequency and the height and everything else look the same, but they totally different how they interact, right? And just for analogy, imagine that you see those people that do with skateboards and they're going down, let's say 10 feet drop, and they use this energy to propel them to go to the next one, right? Imagine exactly the same drop, but now it just
There's no transition.
there is no transition. It's 90 degrees go. So now when they fall, they get an impact. And the impact cannot be then used to propel or to use that
Yes.
energy. It's just destroying or impacting them actually.
Negatively.
And, yeah, and this is really similar first to understand what's the difference between analog when somebody says, oh, we have radio wave, whatever. So it's a little bit different than that. So we in a second going to go and try to understand. And I ask the people, just so they give them, the people that actually know. And I tell them, well, each one of us did probably a few times in his life an X-ray, right? And the X-ray actually is a 1 million time, more energetic than microwave, right? So, and you say, well, if this is so energetic, how come you've been allowed to do it, right? So what's you did it. So if the guy will tell me, well, because this was a very
Short amount of time.
Short amount of time. So the exposure time was extremely limited. And my following question is that, okay, so tell me what's the difference between 1 second of exposure to X-ray to 1 hour? Because the energy don't go up. What's actually happened? And in order to kind of make it so people understand, the difference is what we call intensity, right?
Mm-hmm.
Or we're calling it accumulations. So in other words, but if we want to even understand it more, it's really, think about it, the quantity of the photons. So in other words, when it's like I'm throwing on you 1 stone, right? So even if it's hurt you, it's not a big deal. But imagine that I'll throw you a lot of them, or for a period of time, eventually it's going to make a damage, right? So this is really the analogy, right?
Yeah.
Now let's see how. Again, it's not me trying to explain it, but I think everybody know about it, but they just don't telling you, because in real life, it's not about how much energy that photon has. In real life, we're using it on a power, right? We say 1 watt, 2 watts, 30 watts, right? And so what actually we said, so the power is measured by joule per second, right? And what it is, if we're going back to what I just explained, we actually, because the formula of power is like how many electric photons they contain energy time how many it's like a weight, right? So if it's like telling you what's heavier, a kilogram of metal or a kilogram of feather. It's exactly the same, right? But in order for the kilogram of feathers to be 1 kilogram, you just need a lot of them.
Yeah.
This is very similar. Now listen to the things. It's very similar. So in order to have a 1 watt of microwave, we need 1 million more time. Not more, but time than the X-ray we need for the same 1 watt, right? You remember like the feather? So in other words, we will have a sheer amount, much more, millions, because it's time 1 million, about time 1 million more photons in the microwave compared to the X-ray, right? And we just said before that what's actually making the damage is not the energetic level in that short exposure, but the sheer amount, the amount of the energy that actually interacts with us. Accumulate, right? So here, when you have a very little energetic level, like the microwave it is, right? You just have a sheer amount. You have billions of them that actually basically bombarded on you.
Yeah.
And what we learn, and that's our study and what we talk about, that we biologically interact with that energy. And when you have so many of them, the chance of interaction rising in the same level. So even though the X-ray is actually more energetic, just for example, or the visible light is about 250,000 times more energetic as compared to the 2.4 gigahertz, let's say, of Wi-Fi, or UV light, which is about 400 times more than all of those. It's true that they contain more energy, but they have less amount, which actually accumulate to that exposure and to the interaction biologically, which we find out that actually making those damage that we talk about.
Yeah, I think something that immediately comes to mind is anybody who had like I don't know, in elementary school or middle school science class, we learned about like erosion, which is, or weathering, how nature impacts different stuff. And it's interesting because you talked about the concentration before, and a really good example I think many people will be able to relate to is that if you take, let's say, the X-ray, which is like a stronger version. So let's say like a big bucket of water, and you just one time you pour the bucket of water on this big stone, it's not gonna do much. But if you have even a small drop that's very concentrated and accumulates over the years, it actually can create a hole in the stone. And now, like we said, it's a difference between, you know, a big amount, maybe, you know, every once in a while, versus a small amount that just accumulating, concentrated at one point. The same thing with sunlight, right? Sunlight, we're all exposed to the sunlight. Nothing, I mean, it's fine. But if you take a magnifying glass and you concentrate the sunlight, it becomes so powerful you can, you know, light a leaf on fire on the ground. All the kids do it, or they kill the little ants and stuff. So I think maybe that's something that can make it clear for people to understand.
Yes, and I think what we find out that is not just the amount or the energy about it, but what it is really the interaction biologically, because our body designs to get information. Like I give the samples of if I touch you, you know, and your brain need to react. So, and if I touch you millions of times per second, your brain will not be able to react. Now think about those things that interact biologically, and the body try to react to it, and it's constantly, and it's without stopping, and it's with sheer amount of them.
Yeah, and it's unfamiliar to the body.
Yes, and this is very extremely documented. What we talk about that, and people need to understand when they say about, you know, visible light or ionizing compared to non-ionizing, that's not relevant. What we focus about on that radiation is how those photons really interact with the body and what they can cause. And because of the amount of the photons, not the intensity of the photons, it's what's actually create this interaction, because interaction is about quantity and less about the energy itself.
Yeah, I mean, even if the radiation just doesn't have enough energy to really, you know, mess with the DNA like ionizing, it's just the fact that your body has all these biological processes that it does by itself, right? Your brain, it's unconsciously doing that stuff. And what happens is when you have this unfamiliar source, you know, even poking it a little bit at a time, which is like the cell phone radiation, then actually it's giving attention to, you know, understanding what that is and taking that and actually not maybe doing its normal job a little bit worse, like regulating your bodily temperature, regulating your pH, doing all of these things that unconsciously it does. Suddenly it has this external factor that it needs to take care of, and it's maybe not doing what it's supposed to at its best level.
Yeah, and for example, let's say just for example for the UV light, right? So we mentioned it, and like what we said, it's about 400,000 times more energetic, but it's actually all stopped with the skin, right? So it's actually, that's why we have skin cancer, but it's because it's becoming only the skin. So even paper can block radiation of the UV. But you know what? Microwave, why they're choosing it to heat people, right? Because it's penetrating. It's going much better than the sunlight through walls and through people and through subjects. So, and there is reason why they choose it to be the Wi-Fi, and unfortunately they also use the same one to heating people, to heating the microwave, heating food, right? So they're actually using very similar wavelength, and so you see, like when you're talking about it, this is really trying to take you out of the subject. It's really not relevant if ionizing is more dangerous or less dangerous. It's represent obviously a certain risk, but we're talking about something that we use nonstop. We expose to ourselves nonstop, and understanding, and again, all the studies to support all those things, we have it, and we know how much it's actually bioactive agent. And if it's a bioactive agent, we have to have measurement. We have to have what it's allowed, not allowed, how to use it. We don't have all that stuff. So we know from one hand that it's extremely bioactive or bioagent, and then in the other hands we have none, safety or anything to tell us about it.
Yeah, just the other day we were thinking about that, and we gave the example of, for example, Motrin or Tylenol or all these like ibuprofen, these medicines. So these are things that react biologically with the body, and there's clear instructions on the box that tell you, listen, if you're over 12 years old, if you're over this weight, whatever, you can use this amount.
Yeah, it's telling you no pregnant woman, no kids. There's
Yes,
a reason,
if
right?
you're under, use this amount. But the crazy thing is with the cell phones that there is no guide, there is no regulations, there is no limitations. Like if you weigh this much, if you're this old, if your brain is developed, if it's not developed, none
if
of
you're
these things.
sick, if you're healthy,
None of these things are taken into account, and not even close. And the problem is that people are so addicted and reliant on these things that they're really exposed to it at the maximum level. And it's really, like we said, it doesn't leave you ever. It's always by your head. It's always near your bedside. It's at your job. It's in your pocket. It's never leaving you. And the fact that we don't have these instructions for this bioactive thing is crazy.
I definitely agree. I think this is it's almost like negligence, because what we know compared to what we actually relay to the people that actually using it. We at Bodywell, we long time ago, we knew that this is just expand. This technology is just going to be more and more. This is the nature of this technology, right? We're going to be more and more dependent on it.
Yeah.
Before, kids will not learn, but today, in order to just learn in school, you need to be attached to some kind of those devices and leave this arena just without any considerations of the medicals, biologicals effect is kind of really if they don't do it, we have to do it.
Yeah.
We have to take care of, when we know, we have to take care of our loved ones and do whatever we can to mitigate, minimize, reduce this exposure.
Great. So I'd like to kind of summarize and make it easy for people to share with their friends when people ask. So if we summarize, there's a difference between natural radiation and man-made radiation. Mainly the difference is in the sheer amount, like you said, the absolute quantity, and also the fact that it's abrupt, it's chaotic. That means it's very different from any other sort of radiation that's in the spectrum.
Yeah, we actually says about that analogy is like if you have a big, heavy hammer and I put it on the table, nothing going to happen to the table.
If it's static.
Right, if it's static, right? And now imagine that it's vibrate and rotate and whatever, that's going to destroy it. That's
what jackhammers are. That's how they break concrete.
Exactly. That's the modulations elements that we have on this technology. It's a very chaotic and disruptive and destructive to ourselves.
Exactly. So yes, this chaotic nature specifically of cell phone radiation, that doesn't have to do with the frequency, with the power, with all of these things. This specific radiation, because of the modulation, because of all these things, is why it's disruptive to your health, and it's why it's the one that causes the biological effects that most people are not taking into consideration.
I agree.
All right, so I think we covered everything for this episode. Thank you so much. As always, guys, if there's any other further questions you guys would like to know, please ask. You can reach out to our team. So thank you for watching, and if you found this interesting, you could share it with your friends and family. I think it's important for everybody to know. And
knowledge is power.
Definitely.
Thank you.